Hello everyone, my name is Ankit Chahar and today I will be presenting my midterm project for the course Introduction to System Engineering. The topic of my presentation is human-robot dealing using Boston Dynamics Spot Robot as a case study. Human-robot collaboration has become an important area in robotics because it allows humans and intelligent machines to work together to solve complex problems. In this presentation, I will discuss how Spot Robot demonstrates key system engineering principles, including need analysis, concept exploration, system design, and challenges in deployment. Now, yes, coming to human robot teaming, it refers to a system where humans and robots collaborate to complete tasks together. Unlike traditional automation systems that try to replace human workers, human robot teaming focuses on combining the strengths of humans and machines. Humans are good at decision making, creativity, and understanding complex situations, while robots are good at precision, endurance, and data processing. By combining these strengths, human robot systems can perform tasks more efficiently and safely. This concept is now widely used in many industries such as manufacturing, healthcare, logistics, disaster response, and space explorations. This is an example of an image showing how robots can be used in collaboration with humans in different tasks. So, yes, as I was talking about, this collaboration is becoming increasingly important as many modern challenges require advanced technology and human oversight. For example, robots can operate in dangerous environments such as disaster zones, nuclear facilities, or many hazardous industrial sites. In these situations, robots reduce risk to human workers while still allowing humans to supervise and control the operation. Another important benefit is improved productivity. Robots can perform repetitive or physical enduring tasks while humans focus on planning and decision making. As a result, human robot teaming improves the efficiency, safety, and operational accuracy in many industries. Now, coming to the concept development stage, one of the most advanced examples of human robot collaboration is Boston Dynamics Spot Robot. Spot is a quadruple robot, meaning it walks on four legs instead of wheels. This design allows it to move across terrain, stairs, slopes, and confined spaces that would be difficult for wheeled robots. The robot integrates advanced technologies such as camera, LiDAR sensors, and inertial measurement units, and many AI-based control systems. These systems allows the robot to perceive its surrounding, navigate complex environments, and collaborate with human operators in a much better way. Spot robot is used in many industries. One major application is industrial inspection, where the robot monitors infrastructure as pipelines, power plants, and manufacturing equipment. In construction, Spot can inspect sites and collect data about project progress. In many public safety, the robot can enter many dangerous environments to assist with disaster response or search and rescue missions. It is also used for environmental monitoring, where it collects data in remote or difficult locations. These applications demonstrates the versatility of Spot Robot as a robotic platform. These are the various examples showing the Spot Robot in action across inspection sites or warehouse automation, be it in safety or security, and even in some research and development areas. From a system engineering perspective, the development of Spot Robot begins with the concept development stage. This stage focuses on understanding the problem, stakeholder needs, and system requirements. In case of Spot, the main challenge was creating a robot that could operate in unpredictable environments while collaborating with humans. Stakeholders include engineer, emergency responders, industrial operators, and regulatory organizations. Each group has different needs, right? Such as mobility, reliability, safety, ease of operation, and adaptability. By analyzing these requirements, engineers can design a system that meets the need of all the stakeholders. The next stage in system engineering is concept exploration, where different design approaches are evaluated. For Spot Robot, many key concepts were explored. One concept we call is task-based adaptation, which allows the robot to challenge its configuration depending on the task. Another important concept is human-robot collaboration, where humans supervise and guide the robot. Spot also incorporates enhanced autonomy, allowing it to navigate environments using sensor data. Finally, the robot can work in multi-robot systems, collaborating with drones or other robots to complete the missions more effectively. Spot Robot includes several important capabilities that makes it more effective. First is the mobility. Since its quadruple locomotive allows it to move across different terrain and maintain stability in many complex environments. Second is sensor integration, which allows the robot to perceive its surrounding using camera, lidar, and other sensors. Third is modularity, meaning additional sensors or equipment can be attached depending on the mission. Finally, Spot supports human-robot interaction, allowing operators to monitor and control the robot remotely. Now coming to the demonstration, Spot Robot demonstrates how system engineering integrates multiple technologies into a single functional system. The robot includes many subsystems such as mechanical components, sensors, software components, communication systems, and many user interfaces. These components must work together seamlessly. For example, the perception system gathers environmental data, which is processed by control algorithms to guide the robot's movement. At the same time, communication systems allow human operators to monitor the robot in real time. This integration of subsystem is the key principle of any system engineering task. Now, despite the many advantages, the Spot robot also faces many challenges. One major challenge is the cost, as purchasing and maintaining the robot system can be expensive. Another challenge is technological reliability, since failure in sensor or software could disrupt operations. Energy efficiency is another limitation because the robot relies heavily on battery power. These are the major concerns. Other than that, we have concerns about public acceptance, privacy, and many regulatory compliance, especially when robot operates in a public environment. To challenge these, we have many migration strategies which can be applied so that we can address them more effectively. Now, coming back to the data infusion and integration part, right? So, we want to integrate various sensor data types to create more comprehensible and environmentally sustainable models. These are some of the core functionalities which we would have included in the Spot robot. It would have mobility and locomotive, as I already told, sensor integration, customizability, and the inclusion of human-robot interaction. The various applications could be the disaster response, industrial automation, construction, environmental sensing, and the public safety. To address the various uh, challenges, as I previously mentioned, one strategy is to use modular architecture, which allows the robot to be upgraded without redesigning the entire system. Another approach is implementing fault detection and redundancy systems to improve reliability. Improving battery technology and power management can extend the operational endurance. Finally, organizations must also establish ethical guidelines and cybersecurity protections to ensure safety and responsible deployment. The major challenges which I mentioned would also include the cost, high acquisition and maintenance cost also pose a financial challenge, as I told, for the organization. We are heavily technological dependence on spot robots. Reliable would also be a challenge. Limited autonomy. So achieving a full autonomy in complex environment can be a challenge. Having energy efficiency, public perception, how ensuring is the public perception, acceptance, and addressing concerns like job displacement. Now, regulatory compliance, such as complex regulatory landscape, require adherence to safety, privacy, and ethical standards. Now, mentioning the data security and the skill gap, right? So we have to provide specialized training and accessible programs for the operators. We would also have to keep in mind the ethical use for this. Now, in conclusion, I would want to say Boston Dynamics Spot Robot represents an important advancement in human robot collaboration. By integrating these advanced mobility and sensoring technologies and intelligent systems, the robot can demonstrate how humans and robots can work together effectively. From a system engineering perspective, the Spot Robot highlights the importance of requiring a deep analysis, system integration, and stakeholder collaboration and concentration. Although challenges remain, continued research in the robotics and artificial intelligence will further improve these systems. And the future human robot collaboration will play an important role in improving safety, efficiency, and innovation across various fields. And I believe firmly that together with system engineering, we can achieve all of these tasks successfully. Thank you.